Execution-guided code generation uses real-time execution feedback to teach language models how to code better. Most language models, LLMs, generate an entire block of code based on patterns they've learned from static text. They write the whole solution first, then check if it works. This is like writing an entire essay without pausing to reread a single sentence. This cycle is generate, test, fail, repeat. Execution-guided classifier-free guidance, EG-CFG, mimics how human programmers work. It generates code line by line, running and testing small pieces as it goes. This provides constant, real-time feedback to guide the generation process. This cycle is generate line, test line, guide, repeat. Let's go over how it works. At each line, instead of writing just one continuation, the model uses beam search to generate several potential next lines of code. Beam search keeps a small number of the most promising paths open at the same time. This number is called the beam width. Each candidate line is appended to the current code, and this partial program is executed against test cases. The runtime behavior, or the execution trace, is captured. The execution traces are fed back into the model as a guidance signal. This helps the model decide which token to generate next, steering it towards a correct solution. Let's say the model is trying to write a function, such as first non-repeating characters. It has already generated the first few lines. Now, it needs to decide what comes next. For car and S, we can see the trace feedback has a match and understands what that possible line does. Now, the candidate for the next line, for car and car count, we can see it understands a line, but sees it not as relevant. It knows return none ends the function, knowing that it has a negative signal ending that trace path. The power of EG-CFG lies in how it creates and uses the execution feedback signal. It's a constant loop of exploration and guidance. Let's break down the full cycle that happens for each line of generated code. We begin with the starting point by creating a partial solution. Let's call this prompt PSOL. The model generates several different candidate continuations for the next few lines of code. This is like a programmer thinking, what if I try this, or maybe this? Each candidate is temporarily added to PSOL and run against the provided test cases. The model records exactly what happens, variable values, errors, return values, etc. This creates a detailed execution trace for each candidate. All the execution traces are bundled together into a special dynamic signal prompt. This prompt, PDYN, is essentially the original prompt, PSOL, but with all the execution feedback injected into it. It tells the model, here's what happened when I tried a few things. The core and important step is guidance. CFG guides the model's next decision by comparing two scenarios. PSOL is what word would you normally predict, and PDYN is with all the considerations and feedback. What would you predict next? The cycle then repeats for every token. Benchmarks are shown below. For a more in-depth understanding, be sure to check out the GitHub free code. You can paste this code into Gemini or other LLMs and have your very own interactive tutorial.